Hello everyone. So today we are going to solve minimum number of arrows to burst balloons. So this is a median level question. So first let us go through this question. So they given that there are some balloons which are attached to a flat wall. So these balloons are basically in a spherical shape. They are attached on the flat wall. So this flat wall can be considered as an XY plane. So the balloons are represent as a 2D integer array points where points of I equal to x start comma xn. So what does this means is, so let me show. So the input format will be a 2D array. So in this 2D array, each balloon is represented as a 1D array. So in this 1D array, there are two elements. So the first element represent the starting point of the balloon and the next element represent the ending point of the balloon. So if we take an example, so you can consider this as an wall which basically represents the xy plane. So let me show you how this 1 comma 6 balloon looks like. So consider this as an wall. So since they mentioned a balloon has starting index from 1 until 6, so these balloons start from the x index 1 and end at x index 6. So although this doesn't look like a sphere, just consider it as a sphere. So now I hope you got an idea how a balloon looks in xy plane. So let me go through the question. So the next the given is arrows can be shot up directly vertically in a positive y direction from a different points along x-axis. So what they mention is, so you can shoot the arrows in a positive y direction, which basically upwards at any point. So you can throw the arrow at point x point minus 6. You can throw an arrow at x point minus 5. You can throw an arrow at minus 5. So your ultimate aim is to brush the all the balloons. So a balloon with x start at x end is burst by an arrow if and only the if the x is between the x start and x end. So what they mentioning is, so if an arrow is going to burst a balloon, so it should be in the range of the balloon. So what basically they mean is, so here we take an example of this balloon. So this balloon lies in between, the diameter of this balloon lies between, so 1 and 3. So if I'll throw an arrow. So this arrow should brush this balloon. So the only necessary condition is this arrow which I'm throwing should be lying in 1 and 3. So this arrow throwing X position should be in between 1 and 3. Then only this balloon burst. So the another point they're mentioning is, so an arrow keeps traveling up infinitely, bursting the any balloon in its path. So basically what does that mean? So if I throw an arrow at position number 3. So since this balloon is also lying under 1 and 3, so then this arrow pops up this balloon. So after popping this balloon, this arrow still continues to travel up. And again, a balloon which is ranging between two position in x index 2 and x index 4. So since the arrow throwing index is 3, so the arrow passes through this balloon also, and this balloon also pops. So it this arrow travels infinitely upwards, so that any balloon which comes in the path of this arrow, so the balloon will be popping out. So basically this statement means that, okay. So and given the arrow points, return the minimum number of arrows that must be shot to pop all the balloons. So the input array is nothing but the positions of the balloon, the starting and ending index of the balloons. So we should return the how many minimum number of balloons, sorry, arrows, so that we can pop all the balloons. So now the question arrives. So how to find the minimum arrows to pop all the balloons? So one thing you can do is, so you can throw uh, every unique arrow to pop all the balloons. So for this balloon you will throw in one arrow. For this balloon you will throw another arrow. So for all the balloons you throw one arrow. So then the total number of arrows to pop all the balloons is which is nothing but the total number of balloons on the wall. So if there are n balloons, so So basically we need n arrows. So is n arrows necessary required all the time? So the answer is no. So why? Because we already know that. So in this case, if we take the previous example, in this case, if I throw a single arrow, it's going to pop all the balloons which is in the path of this arrow. So basically, it pops this balloon which lies in the 1 and 3, and also it also pops which is basically in the balloon which is starting from 2 and ending in the 4. It also pops if there is any balloon other than these two balloons above. So if there is a balloon which is coming under this arrow's range, so that balloon also pops. So now you got to know that. So some of these balloons which are overlapping doesn't require an each unique arrows. So one arrow is enough for popping this all the overlapping balloons. So you got the idea. So now your one thing you found out is, so for overlapping, basically overlapping. Sorry for writing. So for the overlapping balloons, overlapping balloons, so you need a single arrow balloons. So you need a single arrow. So now the number of arrows which is total required will be less than n, where when we have an overlapping balloon cases. So which balloons can be considered as overlap based on the input? So here we will see once. So if you check this array 1 comma 6, so it is going to start from 1. So it is going to end. So let me wait. I will rub this. So here one balloon is starting from 1 to 6. So the balloon lies between this 1 and 6. So if you take in the second balloon, it starts from the 2 and 8. So we don't know the y position, so it can be anywhere, but the balloon basically lies between the x range y2 and 8. So suppose 8 is will be there. So since here we can see that these two balloons are overlapping. So one arrow is enough to burst these two balloons. So that is a basic idea to solve this problem. So the first thing we will do is we'll sort the array, and next thing we'll do is we will find out the which are the overlapping balloons, so that one arrow is enough. Okay. So the first thing we will sort. So if we'll take this example. So the next question is, so from so the balloon lies between 1 and 6. So from which x position will you throw an arrow? So I can throw it at position number 1. I can throw it position number 2. I can position number 3. And 1 to 6, in between 1 to 6 I can throw arrow at any position. So where should I throw my arrow? So that is simply, so I'm saying that I will throw my arrow at the last position, basically the ending position of the balloon. So why? So, basically, I'm saying that if an other balloon is between some 12 to 14, so I will be throwing my arrow from at the 14th index. So if the sphere lies between 1 and 6, I will be throwing my arrow at 6th index number 6. So why only at ending index? So basically, the simple reason is, so if there is another balloon, so next to this balloon, I mean, next to the index of this starting index to of this balloon. So basically, you can take this example of this balloon. So if I throw my arrow at position number 1, there is an uh, chance that it misses this the next balloon. So which is an overlapping balloon. So it is overlapping. But if I throw my arrow at position number 1, so it misses the overlapping next balloon. So but when I throw my the arrow at the ending position of the first pair, it compulsorily goes through this the overlapping balloon. So you take any other overlapping balloons. So when I throw my arrow at the ending index, it definitely passes through all the overlapping balloons. So now you got the idea. So why we should throw at the ending of the ending of the sphere. Why we should throw the arrow at the ending of the sphere. Okay. So we should find them. Okay. So first we will find out how we are that is overlapping or not. So we'll check the 1 comma 6. First we'll take this first pair. So 2 comma 8. The next balloon is 2 comma 8, which is basically overlapping. So I will throw my arrow at index number 6. So then it pops out this balloon. So it also pops out this balloon. And the next balloon which is lying between 7 to 12. 7 to 12. So basically this is 7 and this is 12. So I'm throwing at index number 6. But if you check that these balloons are overlapping, but this balloon is not overlapping with this balloon. So I need to throw a new arrow so that the arrow passes through this element and the element the other balloons which are overlapping to these balloons. So now I need for these two I need a one single arrow. So for starting from this balloon I will need a second new arrow. So I'll throw in second new arrow at the last position ending position of this balloon. So I will throw at the balloon at arrow at the index number 12 so that it also passes through the overlapping balloons of this balloon. So the overlapping balloon of this 7 comma 12 is which is nothing but 10 comma 16. So the 10 comma 16 which basically overlaps between here so that this arrow also pops to this the single arrow. So the total number of balloons required is 2. So it is okay. So let me show you my code. Mm. So the first thing here I'm doing is I'm sorting. I'm using an custom comparator. So based on this second element of this arrays, so the array will be sorted based on the second element of this arrays. So here the max indicates my arrow throwing position. So I'm setting this my max to the first element ending index. So this is the first element. So I'm sending this setting this second element ending element ending index as an arrow throwing position, and also I'll setting my arrow count. So basically since I'm throwing at ending index at 6 one arrow, so I kept initialized as 1. So let me go through this loop. So if so here I'm checking if a of I of 0. So basically what that means, so a of I of 0, so that basically means the first element is greater than max. So if 2 is greater than max, so that is basically to check whether they are overlapping or not. That is simple, whether my arrow throwing position is in between 2 and 6 or not. So if that is overlapping, so if that is overlapping, then it is not a problem. If it is not overlapping, so I need to increment my arrow. So I should throw a new arrow. I will be setting so my next arrow throwing index position to the next ending position. So which is basically 8. So after running through this loop, you will get the total number of arrows. So let me submit this code. So it passes all the test cases. Okay, thank you.